Hello, my name is Damian Ball, and I'm here at the University of Idaho College of Engineering 18th Annual Design Expo. I'm joined by Walter Teresh, who's going to talk about his project. Walter, can you describe what you've done today?
So our name is Team ARC. We're the team for apparatus for removing cadmium, and we are contracted by INL. That's our client and sponsor. INL is Idaho National Laboratories. It's down in Idaho Falls, Idaho. So basically, our project deals with an electrorefiner in their argon hot cell, and what that is they take spent fuel rods and they treat it in a pyro process to remove the low radiation material from the highly radioactive material. So what happens in this process is there's two gases, lithium chloride and a potassium chloride, around this electrode assembly shaft, and the gases act as the anode and the shaft acts as the cathode. And when they heat this up to 500 degrees C, there's a layer of cadmium bath at the bottom, and when that heats up, it vaporizes and condenses on the shaft in this area, as you can see here. So what they want us to do is make a tool that will remove this cadmium easily. They use it robotic manipulators from the outside of the refiner, from the hot cell. So these are 5-inch thick walls around this hot cell. So these manipulators are controlled from the outside, and they basically, right now, they take tools from the handling station and they file and scrape off the cadmium as it is. So they want us to do a tool that's not as hard on their manipulators and is easier on the shaft and takes less than 3 to 6 hours, which is the normal cleaning time. So they do this once a week. They would like this to last at least 100 cycles. One thing that we're working on is trying different types of removal methods. We started out with a lathe bit and a file bit like they use, except have an arm that works in rotation with the shaft and a vertical motion. But we found that these pitted the shaft way too much, and so we went on to a wire wheel method. Basically, they can insert a motor into this hot cell without damage to it and spin this wire wheel against the shaft, and that's kind of where we've taken our project. If you can see over here, this is the tool. This is the tool that we've designed. So how it works is these manipulators come in, they can handle the tool. Right now, their overhead assemblies can handle the shaft and handle lowering and raising it and rotating it. So our tool comes in and basically it's spring-loaded to help aid in the force that we want against the shaft, and all the components are made to help in the ease of use with the manipulators. So we can give you a demonstration here real quick.
Yeah, that'd be great. Thanks, Walter.
So I'll turn this on. So this would mock their movement of the shaft. Right now, this would be the handle for the tool. They could come in, take this out of its pivot point, let it ride against the shaft until it starts removing cadmium, as you can see. Then they can lower and raise that in any, in two directions and take off material. From there, hopefully our shroud will catch the material. That's one of the requirements that they wanted, was some kind of device that would capture the cadmium.
So, was that radioactive material we just got all over us?
Anything that they put inside the hot cell is going to be radioactive. The cadmium itself will stay in for as long as, again, they brush it up and put it back in the cell. Okay, so that's kind of where we landed on our process, is that the shroud is our last design.
Excellent. Thank you, Walter. So again, my name is Damian Ball, and we're here at the 18th Annual College of Engineering Design Expo. Thanks.